So this software has nice visualization tools to really understand what's happening when you find a Fourier series. So I'd like to do some examples to see what's going on. Here I'm taking n equals 5, which means I'm going to find the first 5 terms in the infinite Fourier series. I'm going to find the terms for the function f of x equals x. If I run this command, it first gives me the complex form of the Fourier series, which then, using the last command, I've turned in to trig functions again, because I feel more comfortable looking at the sines and cosines. The assumed interval this software uses is L equals pi. So I'm working on the interval from negative pi to pi. So here are the first 5 terms on that Fourier series. I'm going to plot the function and the Fourier series together to see what happens. So the blue line, that's the function f of x equals x. And the gold function is the combination of signs that is closest to the function f if I'm only permitted to go up to 5 terms. So these are the first 5 terms. If I increase n, so let me increase 5 to 10, then I'm going to increase the number of terms in my Fourier series up to the 10th term. My picture is also going to get a little bit better. So the gold curve still has wiggles in it, sine has wiggles, but you could see that it's getting closer and closer to an approximation of the function f of x. So let me increase that number of terms to 20. So I have the first 20 terms, I could plot that. And yes, this gold function is getting closer and closer to my line. Let's go up to 50 and see how good this could really be. So I have the first 50 terms in the series. I can plot that, and I could see, yes, indeed, a very accurate picture of the approximation to my function f of x using Fourier series. Now, this approximation is excellent the more terms you add. In fact, if you take an infinite number of terms, you actually get equals. It actually is equal on the interval from negative pi to pi to the function f of x equals x. However, this is only on the interval from negative pi to pi, or negative L to L. If I increase this interval from like negative 2 pi to 4 pi, watch what happens. So I'm going to plot the same Fourier series along with my function, and you could see that my approximation is horrible off of the interval from negative pi to pi. In fact, this gold function repeats itself every interval length of 2L. You can see it repeats itself over and over again because sine repeats itself over and over again. The sine functions are periodic, so therefore combinations of sine functions are periodic, and you'll always get this repetition property off of the interval from negative L to L. But on the interval from negative L to L, perfection, perfection. All right, so let's go back to our interval from negative pi to pi. And this time, let's change our function. So a next example that we did in one of the videos was to find the Fourier series for the function that is 0 if x is negative, and pi minus x if x is positive. So I calculated the Fourier series for my new example. Oops, I should do f of x here, not x. So here is the Fourier series for this new example. I have the complex form, and then I turn that into the more comfortable cosines and sines. I'm going to plot my function along with this series, which only goes up to the n equals 5 term. And you could see that the gold combination of sines and cosines is following along pretty closely to the blue function. If I increase n, of course, the accuracy could only increase. Adding more terms can't decrease the fidelity of my approximation. So I'm going to increase this to 10. And I get a more complicated expression, but maybe you saw that the gold function was getting a better and better approximation to the blue function. Let's go up to 50 and see what happens. This might take a second for my machine to do the calculation. Whoa, okay, so here we go. There's the Fourier series up to the 50th term. So you can see I have a sine 50x term and I should have a cosine 49. I guess I don't need a cosine to the 50th term. When we did this calculation earlier, I think if you plugged in different values of n, it would follow that you only get the odd cosine terms out. So let's plot and see what happens. Yes, yes, you can see that the gold function is getting closer and closer to the blue function. There's a near the discontinuity. So there's a discontinuity at 0 where it jumps up from the value of 0 to a height of 3. And you can see that around that region, there's more oscillation than usual, but that's normal. That's expected for these types of problems. Still, as you take the limit as n goes to infinity, you'll get an exact copy of your function. All right, excellent.